toward the more electronegative atom, such as nitrogen. All right. Look at where those lone pair is. Is the lone pair on the most electronegative atom in the group or the least? The most. Electrons stay on the most electronegative atom, right? All right. Now look at this one. What's the electronegativity difference in sodium chloride? Well, looking at the electronegativity, and John's got that on his periodic table too. You know where it is, John? Yeah. Have you found it? Let me see if I can find it for you here. Look at all these numbers. Good granny. Difference in electronegativity, he's got that.
2.1.
Is it 2.1? I'm trying to find it on his. Maybe we can look for it. Covalent radius, atomic radius, atomic volume, first ionization, there it is, electronegativity. So your number is on the top right, 2.2. Okay, so like I said, that periodic table is dreamy. I mean, if you take any chemistry, you should get one just to study with because it keeps you from flipping through all these tables. Okay, so what's the difference here? 3.0. This is 3.0 and this is what? 0.9. Subtract them, take the absolute value, and what are you going to get? So is this an ionic bond or a covalent bond? Ionic. It's greater than 1.9, right? Now, that's the chemistry way. Let me tell you everybody else's way. If a metal and a non-metal are present, how's it going to go? Ionic, right? Metal, non-metal, ionic. Metal, non-metal, ionic. Two non-metals, covalent. How do you know if something's a metal or non-metal? You look at the periodic table. Stair-step line. Left-hand side, right-hand side. You see, the more two atoms are divorced from each other, the more ionic character they would have. All right? So I'm just going to squeeze here so I have to turn on that thing for a moment. So like, see, if you're talking about cesium and then something way up in here, that is what? Ionic. Because look, the electronegativity difference would be huge. Now what if you're talking about like from here to here? Well, who knows, right? You start getting a little shaky. All right. But generally, if it is a metal bonded to a non-metal, you would call it a covalent, an ionic bond. And most of the time you would be right. You see, so you may be saying, well, King, why do you tell us all of these things and whatnot? Well, when you take your MCAT, when you take your PCAT or your dental school exam, you may not have nifty-difty table in front of you. They may ask you to use your chemical intuition and common sense to spit back questions. And if you see a compound such as magnesium chloride, is this ionic or covalent? Ionic. Boom, there's a metal and a non-metal. Move along with your life. 99% of the time you'll be right. But take a look at this one. Calcium sulfide. What's the electronegativity? First off, what would you predict? Common sense tells you what? Chemical intuition. Ionic. Metal, non-metal, forget it. Let's run the numbers though, just for giggles. What are they? 1.0 and what? 2.5. So what's the electronegativity difference here? So this is what type of a bond? This is a covalent bond. So this would be an example of a time you would be wrong. Right? So it does happen. And you have to remember when you're talking about periodic trends, when you're talking about chemistry, we answer questions about what happens most of the time. All right? Because you don't want to go and look up every single thing. You want to have a gut feeling of what's probably going to happen. Does that make sense? My wife gets so mad at me. I'll ask her, what time you think you're going to be home? Or what time you think that seminar is going to be over? Or whatever. She'll say, I don't know. I hate that. Do you guys hate that? Do you have a husband or a wife that tells you that?